Okay, so here in this lecture we will discuss about serial adder. Serial adder is a slowest adder. In this serial adder we will provide input serially. In previous lecture we already discussed parallel adder. In parallel adder all input bits are provided simultaneously. Suppose we have to add 4 bits, so at that time 4 full adders are connected into parallel, and at that time we will provide input bits simultaneously. So that's why it works, so that's why its speed is faster. But in serial adder the input is provided serially. Now here A3, A2, A1, A0. Now this block represent the shift register. This block represent the shift register. Before starting shift register, first we have to know that what is register. Register is nothing but a combination of various flip-flops. When several flip-flops are connected, with each other to store any data, so at that time it is known as register. And when this register is used for the shifting purpose, so it will be known as shift register. Here this one is the D flip-flop. Here flip-flop is a memory element, and D flip-flop is used, D stands for delay, so it will provide some delay between input and output. So let's start its working. So this one is the clock signal. This clock signal will activate these registers as well as this flip-flop. So when clock signal is provided, so at that time the LSB of shift register A and the shift register B is provided to the full adder. Okay, but in the same time this clock will also activate the D flip-flop. So when D flip-flop is activated, so at that time this input will reflected in the Q side, and it will provided as an input in the C in. So full adder gets all 3 inputs, and accordingly it will generate sum and carry. Okay, so this carry will stored in this flip-flop, but it is not reflected here. So when this carry is reflected here in second clock pulse, when we provide second clock pulse, at the time when A1 and B1 is provided as an input to the full adder, at the same time when the clock is provided in the D flip-flop, at that time the previous carry that is stored in this flip-flop will be executed, will be reflected here. Okay, so after the addition, next sum bit is generated. Okay, so this sum bit is first stored in S3. Then when second sum is occur, so the bit that is stored in S3 will be shifted towards the S2. Okay, in the third case, when third sum bit will occur, so at that time the bit that is stored in S2 will be shifted towards the S1. The bit that is stored in S3 will be shifted towards the S2, and the last sum is stored in the S3. Okay, so when we provide the last clock pulse, at that time this last bit, that is A3, is provided as an input to this A and B, and the previous carry that is stored in the flip-flop will be reflected here. So the full adder will add all these 3 input bits and provide the sum and the carry. The last carry will be act as a C out. Okay, and the sum will be stored in this shift registers. So this is all the working of serial adder. Thank you so much.